Hello, you're watching a Unipro UGENE podcast. From this video, you'll get an introduction on how to use FastQC and Trimmomatic tools for checking and improving quality of your raw next-generation sequencing data in UGENE 1.32. No matter what kind of task you solve using an NGS technology, the first thing you usually need to do with the data received from a sequencing facility is to check their quality. We check general information about the data, such as the number of reads and their lengths, sequencing quality scores of nucleotide bases in the NGS reads, presence of adapter sequences that are sometimes added to the ends of the sequenced fragments due to the specificity of the sequencing technologies, GC content of the data. Based on this information, to benefit downstream analysis of the data, we may like to improve the data quality. For example, trim low-quality bases from each read or cut the adapter sequences. To use features described further in this video, you need a computer with Windows, Mac OS, or Linux operating system installed. Standard computer configuration will be enough to run the tools. That is 1 to 2 GB of memory and about 2 GB of free disk space. In this video, we'll use Streptococcus pneumoniae, whole genome sequencing data produced by Illumina MiSeq. The data was downloaded from the NCBI Sequence Read Archive, SRA database. See a link under the video for details. Now go to the UGENE Downloads page, get the recommended online installer package and run it. In the installation wizard, leave the default configuration on the Select Components page. When the installation is finished, run UGENE. Let's use a simple sample workflow with the FastQC tool. Select Tools, NGS Data Analysis, Reads Quality Control, item in the UGENE main menu. Input a file with NGS reads. Note that besides FastQ file format with raw reads, FastQC can process files in BAM and SAM formats. Click Run to run the tool. The resulting HTML report, produced by FastQC for the input file, appears on the workflow dashboard. Simply click on this file on the dashboard to open the report in a web browser. The report contains different sections that can be accessed either by scrolling the HTML page or by using links at the left. In the Basic Statistics section, you can find, in particular, information about the number of reads in the FastQ file and minimum and maximum lengths of the reads. The next section shows range of quality values per each base position across all reads from the file. At a certain position, the yellow box represents the interquartile range, 25 to 75%. The upper and lower whiskers represent the 10% and 90% points. The red background color denotes poor quality base calls. These are quality score values 20 and less. As we can see in general, the quality decreases toward the ends of the reads. Let's also look at the overrepresented sequences section of the report. As we can see, for this input file, FastQC has found that several hundreds of the reads contain Illumina TrueSeq adapter. Now let's create and run a workflow that trims low-quality bases and adapter sequences from the reads. We're going to modify one of the sample workflows for our needs. In the UGENE Workflow Designer, go to the NGS section and double-click on the De Novo Assemble Illumina Paired End Reads workflow. In this workflow, we read FastQ files with paired end reads, pass these data to the Trimmomatic tool, and then pass the trimmed data to the Spades De Novo assembler. Also, we perform reads quality control by FastQC for each file from a pair before and after the trimming. We do not need the De Novo assembly step for now, so we remove the Spades element. The Trimmomatic tool allows you to perform a variety of trimming tasks for the input FastQ files. Click on the workflow element and select the trimming steps parameter at the right. Click on the Browse button that appears nearby to configure the trimming steps and their associated parameters. You can add a step using the plus button in the dialog. The different processing steps are performed in the order they are specified in the dialog, so make sure to set up the order you need. To cut the Illumina adapter sequences, we add the Illumina clip step. It is recommended to perform the cutting-edge adapter step before the other steps. For the MiSeq data, we need to select TrueSeq3 adapters for paired end reads. We select the second file that contains the extended list of adapters. Note that, if required, You may set here any custom FASTA file with adapter sequences. To trim the low-quality bases from the ends of the NGS reads, we add the sliding window step. Trimmomatic calculates an average quality in a window of the specified size and trims the bases if the calculated value is below the threshold. We set the window size to 3 bases. Click the Apply button. The last thing we need to do is to set the input FastQ files. Select the Read Illumina Paired End Reads element and add the first file from the pair to the first dataset field and the second file to the second dataset field. Run the workflow. For paired end input, Trimmomatic produces 4 output files. 2 files with the trimmed paired end reads, notice the P character at the end of the file names, and 2 files with reads that don't have a pair, notice the U character. There are usually a few or none of such reads. Also, we have output from 4 FastQC elements. Previously, we've seen a FastQC report for the first file from the pair before the trimming. Let's compare it with the report for the trimmed data. We see that there are about 250,000 of reads left. Some of the reads were trimmed to 2 bases. The per-base sequence quality is now good enough, and there are no sequences in the overrepresented sequences section. There is still some problem with the per-base sequence content. More specifically, we see some bias at the 301st base. So, we might like to return to the workflow, open the Configure Trimmomatic Steps dialog, and add 2 more trimming steps. The min-len step with the length value equal to 10 to remove very short reads, and the crop step with the length value equal to 300 to cut off the 301st base, if it is present. If we run the workflow again, the report will be good enough. Now we may run the workflow for a number of FastQ file pairs. Select the Read Illumina Paired End Reads element and add the first file from each pair to the first dataset field and the second file from each pair to the second dataset field. Run the workflow. When the workflow is finished, the output files are available from the dashboard, or we can also open the output folder that contains the data. In this video, we saw an example of using the FastQC and Trimmomatic tools in UGENE for FastQ files quality control and improvement. Although we used Illumina data in this example, in general, except the Illumina clip step of the Trimmomatic tool, this can be applied to data received from other sequencing platforms. Cutting of adapters for these data can be performed by the Cut Adapt tool, not covered in this video. Advantages of using the tools in Unipro UGENE are that the tools are provided through the graphical interface and can be easily joined into workflows.